Conduction current is the current which is flowing through the wires, and displacement current is the current which is in the space of the capacitor. So let us solve one by one. So this capacitor is of 20 microfarads, okay, and let the potential be V, okay. So this is at time t. Now at time, let us take at time t plus dt, okay. So at time t plus dt, first of all at time t, so what is the charge which is stored here? The charge stored here is C into V. So therefore 20 microfarads into V, this is the charge. Okay, so charge at time t is 20 microfarads into V. Now charge at time t plus dt, what is the charge here? So now the potential has increased and it has become V plus. Now it's changing at 3 volt per second, so therefore 3 into dt. So therefore now the charge at t plus dt time is 20 microfarads into V plus 3 dt. Okay, why we have written V plus 3 dt? So you can see in 1 second it increases by 3 volts. So therefore in dt time it will increase by 3 into dt volts. So therefore the new voltage is V plus 3 dt, because the original one which we had taken was V. Now this is the charge which is present now. Okay, this is the new charge. So that means how much charge has flown here? So how much charge has flown? So therefore the new charge minus the old charge, this is equal to 20 microfarads into V plus 3 dt minus 20 microfarads into V. So therefore this gets cancelled. So we have 20 microfarads into 3 dt. And of course it is 3 volts per second. So this is the delta Q, the charge which has went, okay, dq charge, okay, dq charge which has went in time dt. So therefore the conduction current IC is equal to dq upon dt, which is equal to 20 microfarads into 3 volts per second into dt divided by dt, gone. So this is simply 60 microcoulomb, sorry, 60 microamperes, okay. So therefore it should be either B or it should be either C. Now a short trick, the conduction current is equal to the displacement current, okay. So displacement current will also be 60 microampere only. However, we will solve this again and we will prove it how it is 60 microampere. So the charge was 20 microfarads into V, okay. Now if you see, this is the formula for displacement current, epsilon naught into d phi e by dt, okay. Now charge was here, the charge was, we'll just go ahead, 20 microfarad into V. So this was the charge previously, like initially at time t, and here the charge was 20 microfarad into V plus 3 dt. Now we are interested in finding d phi e. Now what is phi? Phi is E dot A. Okay, so now what is electric field here? So the electric field in the in the space of the capacitor is actually sigma by epsilon naught, which is basically Q divided by A into epsilon naught. So what is the Q? Which is 20 microfarads into V divided by A epsilon naught. Okay, so this is what? This is the electric field. Now the electric field is perpendicular to the plate area, because the plate is like this. Okay, so it is perpendicular to the area, okay, between the it is perpendicular to the area which is between the capacitors. Okay, so now since the area is like this, the area vector will be like this. So therefore E dot A, okay, is going to be 20 microfarads into V divided by A epsilon naught into A. Okay, which is the initial phi. Based upon this only, the final phi is going to be 20 microfarads into V plus 3 volt per second dt divided by epsilon naught. It should be A epsilon naught into A. Let us do this. A epsilon naught into A. A is gone. So now what is the change in flux? So therefore d phi electric flux is equal to, so this is equal to, we subtract it, so it's going to be 20 microfarads into 3 volt per second into dt divided by epsilon naught, and we divide it by dt and we multiply it by epsilon naught. So dt is gone, epsilon is gone. So again we are left with the same quantity as previously, which is the displacement current, okay, which is again 60 microampere. Okay, so we did with both the methods. First is we understand that displacement current and conduction current are mostly equal, and this is the charging of the capacitor, so it will be equal only. Okay, so we calculated for both. Conduction current is how much charge has flown in the particular time, that is dt. Okay, and we did it, we got 60 microampere. And for displacement current, we just use the formula ID. The displacement current equals epsilon naught into d phi E by dt. Phi is the change in the electric flux. So we found out the electric flux initially, we found out the electric flux finally, we subtracted it, and then d phi E by dt, we found it. Again, the short trick can be like we just find the conduction current, and in the conduction current what we do is we just equate, we just assume both of them to be same. There can be even one more smaller, shorter trick, which is, let us assume after 1 second. Okay, we have assumed it after dt, time t plus dt, after 1 second. So at t it is 20 microfarads into V. After 1 second, now the potential will be V plus 3. So therefore the current will be 20 microfarads into V plus 3. So how much the delta Q has happened? Delta Q is 20 microfarads into 3 volts. So therefore the current is simply, the conduction current is equal to 20 microfarads into 3 volts divided by 1 second, which is again 60 microcoulomb divided by 1 second, 60 microampere. Okay, this is the shortest method. Thank you.